so it was. I'm really excited about the final topic, because it's a religious piece, which is what my interest in history was. And, you got to pick a writer, and so I picked, Mussolini, the Japanese priest. It's a very simple comic, sort of. I have to write 3,000 words on, well, it's nothing. I can run out of 1,300 word paper easily. So it's just double the size of the ones I've been writing. I'm over my stress level. But yeah,
It's called in over your head.
no, because the class isn't donuts for that. The workload, I mean, it's manageable. It was everything else that's going on. And my oven broke yesterday. Day before yesterday, my oven broke. No.
I know.
Yeah, one of the first times oven broke, it was an actual oven, and I was so happy when I got it. And it actually toaster now. I'm very unhappy. That's why I have savings account, to be fair. I will buy you one. I converted a little bit. Still trying to real one this time. But it broke mid making meatballs, so I was very unhappy. Like, my husband was even cooking, all I had to do was mix it.
What?
Because he didn't, my husband does all the time, he's a really good cook.
That's why.
Now I need to dig up the box, I think I still have the warranty, I think it came with a 5-year warranty, so. It only lasted 2 years, so it's not back, I was like, you know, not all of it, I understand, but it didn't even last half the warranty, so.
Yeah, I think I have it too.
Yeah, it's like, I know it lasted about half the warranty, so. That was like half the warranty. Half, doesn't even have to be all of it, just half. I like their products, so if it's half credit for their website, the Wolfgang website, it's cool, I like that stuff, they're pretty durable, so. And they're pretty durable, I mean, very, they don't even have nicks on them, they barely have nicks on them. The Wolfgang book, it's just expensive, so I mean, if you could make half credit,
So 60 seconds and we'll begin on page 298.
use the
Same page.
Oh, you've gotten younger today.
Yeah, had a weekend off.
Is that your secret?
One of them.
Page 298? It's the other one, the philosopher's stone.
Hush.
No, you go deeper. Push.
Hush,
How come you can do it? Push.
because I'm southern.
Is that better?
No.
Push.
He
Push.
sounds like he's 90 when he does it.
I know.
Push.
So cute.
Hush.
Push, flush.
I
Okay,
think
Horse puppy.
in that moment will be the only moment that you
I've
were
got 3
cute,
weeks,
you know?
yeah, my goal. Okay, so we're back. Let's go to page 298 and do some homework. So we're on page 298, number 3. What does it mean when we say that the sample mean is an unbiased estimate? So, Tony, what does it mean if we say the sample mean is an unbiased estimate?
I wrote that it is, they're referring to the mean variance or proportion, but I think it meant more like that it is directly reflective of the population.
No, it doesn't mean any of those. What it means is that just as likely to be above the mark as it is to be below the mark. It doesn't have a bias to be over or under. It could be wrong, but it could be just as likely wrong in either direction. It's not biased. It's not more likely to be above or more likely to be below. So it has no bias. The next part, what does it mean that it targets the population mean?
Oh, I'm sorry.
Yeah, what does it mean it targets the population mean?
That it is close to
Well, it will get
reflect
closer.
very,
The larger the sample size, the closer it will get. So it's headed for it. And if you take a large enough sample, it will get as close as you want. So it targets it in the end. So number 4, Hannah, oh no, this is Tony's. Give 2 reasons why statistical methods tend to be based on the assumption that sampling is conducted with replacement instead of without replacement. Tony, can you give us 2 reasons?
the first one is because the difference is so small,
That's good.
and the second one is that independent events are simpler to calculate.
Yes, right. Those are 2 reasons. Okay, Casey, number 5. You want to estimate the proportion of all U.S. college students who have the, never mind to take stat course, you obtain a simple random sample NYU. Is this a good estimate of the population proportion? Your answer?
I said no, it's only one sample, so it doesn't accurately represent the population.
It says estimator. Now, does proportion target the population? What are our 3 parameters? Proportion, mean, and what are the 3 that target the population? Anybody?
Mean, variance, and proportion.
Good, so proportion is a good estimator of the population. The question is, does New York University represent the general population? Depends on what you think of New Yorkers, I guess. You can go either way on that too. So answers will vary. Answers will vary. Okay? 5, good sample. 6, unbiased. Which of the following are unbiased estimators? Hannah, which are the good guys?
A, C, and D, or mean, proportion, and variance.
All in favor? The others are bad guys. And number 7, Freddie, samples of size n equals 1,000 are randomly selected from the population of the last digits of telephone numbers. If the sample mean is found for each sample, what is the distribution of the sample means? Can you tell us what that distribution will be?
Should it be a normal distribution?
Yes, it will be a normal distribution. Very well done. Perfect
Remember
answer.
why, but
Well, why is, we saw these studies, and let's remind ourselves why that's so. So where's the page of the simulations?
94.
Sorry?
I think it's 294.
Well, that's not a wrong one.
I think it's what you're talking about.
Simulations. Nope.
oh, the computer,
Computer simulations, yes.
Sorry.
so I know we just accepted the fact that it would be within.
No, it's computer simulations. It's been experimentally verified.
Computer proof of
So
it.
what page are they on? It's probably forward. Yes, it is forward. I'm getting close to it now. It's exciting. I found them, 302. There's my,
Oh, you got over?
yeah, I was
It's this
turning
question.
pages. 302, do these distributions all approach a normal distribution?
Yeah.
Well, no matter what you feed in, if n is greater than 30, it approaches a normal distribution.
Looks
Okay.
like cause n is greater than 30.
Got it?
Yeah.
Okay, so Kaylee, number 8. Samples of size n equals 1,000 are randomly selected from the population of last digits of telephone numbers, and the proportion of even numbers is found for each sample. What is the distribution of the sample proportions? And your answer is? Well done. Okay, now, let's go back to Freddie's question, number 7. He's told us it's going to be a normal distribution of all of the complete set of sample means, okay? What's going to be the mean of the sample means? What's going to be the mean of the sample means? What number? What number is going to be the mean of the sample means? Pick the question apart, take it apart. Hannah's good at taking it apart. Hannah, tell us the answer.
Mu equals mu sub x.
Yeah, but what number is it? Mu does equal mu sub x.
The
Bar.
mean is the mean.
What's the mean of the population? If I select single-digit numbers at random, what's their average value going to be?
Oh,
Yes, hang in there, go, push.
well, I was gonna say 5.
Yes, 5. Will it not? If I give you a long list of single-digit numbers selected at random, what would their average value turn out to be? 5. 5. Well, 0 through 9,
Yeah, it adds up to 45 divided by 10 is 4.5.
yeah, 4.5, that's what I was about to say. Yeah.
That's why I said
4.5.
5 and then I went, oh wait.
Oh, all right, I'm catching up.
I
Okay.
only remember.
Now, the next one I'm a little sharper on. Kaylee's question, what's the distribution of sample proportions? She says that it is normal. What's the center point going to be? Center point. Anyone but Tony? 4.5. Yes, it is 4.
A, right, the same,
Well, I want a number.
4.5, right?
No, B. Sig, number 8. Proportion. Proportion of even numbers. Proportion of even numbers. You don't look it up. It's a first grade question. Okay, let's approach it in steps. Casey, can you count for me from 0 to 9?
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, what proportion of those numbers were even?
Oh, 5.
0.5. 0.5. So if you select a long list of random single-digit numbers, the proportion of even numbers is going to be 1/2 in the population. So therefore, in the normal distribution of samples, it's also going to be 1/2 because it targets population. Okay, so now let's go forward. We have 2 questions left, 9 and 12. And I would like to have Tony and Freddie put up 9, and Kaylee, Casey, and Hannah put up 12. Please. Stop. I thought it was just a bluff, I didn't know it was stop. So we need the columns, just like we did in class.
Oh, yeah.
We need the
The one
columns.
like, the black one that's right there is right there. I think. So at the bottom, there's one. I
Alright.
put like a handful in it. Let me know if you can't find them, sorry.
Oh, that's somebody else's.
One, yours is the same as mine, I should say.
Okay. So then, I'm just kidding.
So, nice work. So, also very nice work.
Oops,
Sorry.
sorry about that.
My bad. Tony, you also have such great presentation. Nice work all around. Great, great. Okay, so you can do, you understand. Very pleasing. Freddie's in his Prince Charming pose.
It's Valentine's Day.
Yep. I looked all around my desk for your gift, I didn't see it. I forgive you. Okay, so these are all right and similar. So I'll do a little more presentation now. Page now. So what we have generated is if you want to predict a population mean with a certain confidence level, you let the confidence level lead you into a z-score. And you combine that z-score with the standard deviation of the population and the size of your sample, and you produce the maximum error that you can expect at that confidence level. According to the formula, the maximum error is z alpha over 2 sigma over the square root of n. However, sometimes after you do this, and you say you've generated an error of plus or minus 7 inches on the mean height of the population, given the sample that you use. So you used a certain size sample, sigma for the population, and suppose you used a 95% confidence level, and you generated an error of equal to 7 inches, given those other parameters. Now, what's going to happen to this error if you increase n? The error is going to get smaller.
The largest sample size.
With a larger sample size. Now, why is that true? Because n is in the denominator, agreed? So let's say that error is proportional to 1 over n. So now, if n is 10, then the error is 1/10. If n is 100, the error is 0.01. If n is 1,000, it's 0.001. So as n gets larger, what happens to the error? It gets smaller too. Jason, do you agree? Good. So if you wanted a smaller error, you can't change the standard deviation of the population. You don't want to change your confidence level, because that's what you want to publish. So you don't want to change this, you don't want to change that. But if you want a smaller error, then what is the one parameter that you have some freedom to change? N. So if you want a smaller error, you're going to go to a higher N. Now suppose your boss calls you in and says, this is no good. I'm not going to publish plus or minus 7 inches. I'm only going to publish plus or minus 3 inches. So what do you say to your boss when he tells you that?
We do it again.
Yeah, well, we're going to do it again with what change?
Larger.
We're gonna do it larger N, so you have to give me more people, more resources, so I can sample a larger number if that's what you want, agreed? So he checks his budget and says, okay, go do it to the size that you need. How big a size do you need? Height. Now that's the question. So far, what we have used is that we know N, we know sigma, and we know Z alpha over 2 because we know the confidence level, and we generated E as our answer. Now, we know E. He's told us the limit. He says, I want 3 inches, that's it. E is fixed. Sigma remains fixed, and confidence level Z alpha over 2 remains fixed. So that means N is flexible. So we want to know what size N you need to satisfy a given E sigma and Z alpha over 2. And to do that one time and for all, we need to solve that equation for N. So this is where the algebra gets down and dirty. This is the equation. E equals Z alpha over 2 sigma over the square root of N. So I want everyone to go up to the board and generate N equals. N equals, and see what it comes out to be. Before class today, Hannah said that the math in here was very easy.
I didn't say it was very easy, thank you very much.
For you?
Hush.
You're getting there.
Getting close. Did
I
not
feel
say
like
this was
I
very
am so
easy.
wrong. What'd you get? Oh, I missed something. That's why, hold on, I missed something. Hold on.
I will. I've got to. It's touchy sometimes, though.
Okay, I still think I'm really wrong, but at least I have the part that I forgot.
Are we gonna get 5 different answers?
Probably.
It's looking that way. This is wrong. Okay, so you multiply.
My money's on Freddie.
Oh, okay, wait, why?
Freddie does this stuff well.
Why isn't your whole thing square? Oh, you just. What is it, PIMDAS?
So if you have differences, discuss them.
Multiplication, dividing.
You can do anything you want
This
as
has
long
never
as
been my
it's a
strong
valid
suit.
mathematical step. Basically, you need to be sure you do the same thing to both sides of the equal sign, no matter what it is. Do the same thing to
So-
both sides of the equal sign.
Parentheses.
Can't go wrong.
And then exponents, and then multiplication, division.
Is it
Your
exponents?
money's still in your Freddie.
Oh, yeah, it would be PEN, but. So.
Oh, yeah.
Okay, so. Okay, so if you multiply, because you have to multiply. And multiply this, it gets over here. Square root of n times e equals x. Oh, this should be like this.
I don't know, I'm just
We'll
confused.
see how you did it.
I mean, we're almost there.
This is not my strong suit, so.
I don't know, our thought process is different with the school root and.
Okay, so you put this, you did this first to get this by itself, right?
Yes.
Okay,
try to
so then you
isolate.
have this equals that.
I just tried to isolate and, but if you probably did it.
Can you move this from a numerator to a denominator?
Can you just multiply that and your sigma? Can you have this minus z alpha over two from each side? Cause this will cancel out. I should bring this down. Okay, hold on, let me see. I'm out of.
I mean, I'm saying this isn't my strong suit, but I don't I'm not saying that that's wrong, I just don't know. Should I know?
No. I can isolate sigma, I can't isolate
Cause
n,
when you
my brain is failing me.
multiply, sigma over z over two. Cause this will be up and this will go on bottom.
Everywhere I go about this, I keep getting sigma by itself.
And then you still
No,
got
it's
one
no
here,
numbers.
and then you square.
It's just algebra,
So
rearrangement.
these are opposite.
no mistakes so far.
Is that what you have?
Well, Tony's very close.
I think she might have just done it. I think
This
I'm
this
wrong.
is very close.
I think she just fixed it though, and it's now we're the same. Oh wait. I think I get wrong. I think,
No, sorry,
Even if you divided by, you have
Well,
it flipped
no.
upside down.
it's not,
where?
actually. It's upside down, it's right, but it's upside down.
So I had it right the first
Okay,
time.
now this is right all the way into the last step. This is a right step. So don't erase it. How did you go from here to here? What did you do?
I squared.
You
Oh,
squared,
oh, oh.
hello.
You had it right?
Negative. He's like, you're not even close.
Oh.
I don't understand anything. I don't understand how you're doing this.
So we're trying to find,
Okay, alright, so,
and,
let me use your marker, Mom.
Okay,
so
so,
you took,
so this is the formula, right?
Okay.
Right.
So the first thing I did was, I don't like fractions, so I got rid of the fraction by multiplying both sides by the square root of n. Okay, and then that gave me this formula.
Here.
Do you see how that happened?
oh, you multiplied both sides,
Yeah, because whatever you do one, you have to do by the other.
okay.
So that gave me this formula, but then I want to get n by itself, so I have to get rid of the e, so I divide both sides by e,
Okay,
and then that gave me this.
okay.
Still good?
That's all that math
And then-
stuff.
And then to the opposite of a square root is a square,
Mhm.
so I squared this side, and so I had to square this side.
Okay.
And then you have to get rid of what this is supposed to be. You have to get rid of this, so you have to square these sides.
Good, okay, so this formula is in your book on page 364.
Every time. I'm like sitting here like, what?
Was I here the whole time?
N is equal to z alpha over 2 times sigma all divided by e quantity squared. Now, you don't have to memorize this formula because you can derive it anytime you need it. So when is this formula used? It's used when E has been dictated to you. You're told what E must be. And you're answering the question, how large a sample do I need to sample to produce the E that I've been ordered to produce? So let's do example problem. Page 365, example 2, IQ scores. Please cover up the solution in the book. So Kaylee, could you read the problem to us, please?
Assume that we want to estimate the mean IQ score for the population of statistics students. How many statistics students must be randomly selected for IQ tests? If we want 95% confidence that the sample mean is within 3 IQ points of the population.
Okay, so you write the formula you're going to use. You identify it as being n is equal to z alpha over 2 sigma over e squared. You start your parameter list. E is equal to 3. That's granted. And sigma of the population is IQ points. IQ, it's already always 16 or 15, so we'll take it as 16 for this problem. Well, let's see what they do, 16 or 15. Alpha, they use 15, as I usually do. It's high. And the confidence level is 95%. So that means z of alpha over 2 is equal to a certain number also. And so you find z of alpha over 2, and you plug in all the numbers. So who's gonna first tell me, what did z alpha of 2 over 2 turn out to be? 1 point what? 96, 1.96, we've worked with that number a lot of times already. So when we substitute them in, punch it in. So Casey, do you have an answer?
No, sir.
So at this point, you can lift your paper and see if the author got it right. So Casey, what numerical number did you get in your calculator?
96.04.
Okay, now, are you going to report to your boss that you need 96.04 people in your sample? What are you going to report to your boss that you need? 97. Why not 96? It's not big enough, right? So you err on the side of success. So 97 is the answer. So now I'd like you to, everyone go to the whiteboard and do the following problem, page 366, number 14. And remember, write down the formula that you're going to use.
Never again will I not.
Never say never. please check your neighbors, see if they also did it right.
Oh, what have I done? 2.33. No, don't look at me.
Disagreement, Kay, I see it in your faces.
I think it's me.
What did,
The
it's
alpha over two.
2.33
This is Z-score.
for 99? Did you do 99.5? Should we do 2.57? Because you have to account for the 1% on either side divided by 2.
Oh, that's right, okay.
So this should be your Z-score.
2.57.
2.5
Did you get 82
for the-
first?
Yes. After round, yeah.
After I looked at
So we got that wrinkle ironed out, that's good.
Yep. Your actual numbers seem a little high. Still rounds the same.
So we have consensus closing. Good.
There is two, please. Use two. Sort of, there's an easier, slightly easier way to do this. It says 1%, right? If you eliminate that alpha is 1%, right? That's one of the next one. Alpha, right? So 0.5%. That makes more sense to me. Back up. It's also right here.
Now, check the lower right-hand corner there. You'll find a shortcut, critical values.
Add that times. Don't forget your variation. City times. I think it's the little zeros supposed to be.
Oh.
Let me try.
Okay, next page, 309. 309. Homework time. So number 3 is a repeat. Freddie told us last time, but he's busy right now. So on page 309, Kaylee, can you tell us what the notation mu sub x bar represents?
For number 3,
Yes. It's a mean of the sampling distribution of the means. It's a little bit too quick to say it's the mean of the mean. It's a mean of the sampling distribution of the means. It's a mean of the distribution of sample means. Better. Okay, Tony, what does sigma sub x bar mean?
To have standard deviation of, it should be standard deviation of the distribution of something.
That's standard distribution of the distribution of sample means. You need all the work. Well done. Casey, number 4, distribution of incomes. Hannah answered this correctly last time. See if you can match it. Because the sample is large, can we approximate the distribution of those incomes with a normal distribution? Yes or no?
No,
No, we can't. Why or why not?
it's not a biological parameter.
It's not a biological parameter. That's a very good answer. Number 5, please. And all of these are now whiteboard problems. So wave me off if you don't have the one I asked you to do. Everyone will do 2 or 3 problems. So please write down the ones. 5, 6, 7, 9, 10, 11, 15, 17, 20, and 17 again. So everyone just got 2, I guess. Okay, so let's up these quick.
was no, Mrs. Stephanie, about 190 something? It's 1518.
You probably said it to yourself and heard it as, I don't know, things.
So,
But your steps are right.
is it? So 5 should be 0.4761. So it should be the percent
Sorry, for
for
five.
A, 0.47.
Yes.
And for B was
So actually
0.2912.
So equal, negative 0.055. Or negative 0.066. And then, oh wait, so for B.
B.
What did you do here, 1500?
0.2912.
Over, okay, I should do that.
Is that right?
Negative. And then,
So-
yeah, negative 0.55.
So it's 0.2912, okay? And number, this is, I
So
know,
for 11, I don't know how, let's see. Okay, for 117, I don't know where this number came from. Cause I have 0.4325. Let's look at the chart.
0.4325.
Cause it's negative
Oh.
0.172,
Negative.
right? So negative 0.4325.
So point, was it 0.4?
0.4325.
What about part, what about part B?
Well, but then for part A, you have to subtract it, one. Cause it's looking for the
Oh.
higher, it's looking for above the Z-score, not below it. So 1 minus 0.4325.
That's what I
So anytime they say, if they want it above and you're using the Z-score, you have to
Subtract
subtract it
one.
from 1.
So when it's
Because
below,
the Z-score only gives you the numbers to the left, and you want the numbers to the right.
I am super clumsy, it happens all the time.
It's okay, you didn't damage it.
As long as I didn't trip a break and then we try and
So,
move
and
it.
then it comes out to,
I trip over doors, like hanging
Me
doors.
too.
so if,
I knock
if it,
things off
4,
tables,
5, 6, 7,
do all of that stuff.
and if they wanted above, then you would,
Yeah, because you know how like on the graph, if you're getting the Z-score for this line, right? If they say they want above this line, then they're talking about this part over here, but you're given this part.
So you're talking about number
so
5.
you wanna track one from this one to get this one.
Yes. Number 5, did I do it wrong? Did we do it wrong?
I'm sure that's
Yeah.
right.
Yes, 4761. So that's 11, okay. Yeah, okay, I was looking for it. Like, wait, those numbers are somewhere, what? Yeah, no.
David Charles, David Charles.
Did you get? I got,
Yes, this is,
I got the same one that she did on.
this is
Okay,
A.
never mind.
This is what she did on T, it looks like I got.
It might be easier, I find it easier to start like first and foremost. And then I put it into here.
Maybe it was a calculator, I didn't know where I did it, I had to set up the calculator. Yeah,
Figure out
this is right.
what in the
Right
world I've
numbers,
done
but-
here.
Well,
Oh, we got,
cause you're not really dividing, you're not
Huh.
really dividing this by 29, you're dividing this.
Weighted advanced received for number 15.
Like you're
Or
dividing this
D,
by
excuse
29
me.
divided by the square root of 12.
first,
should
and
be here.
this gets divided by the square root of this,
Right, but
once you
you're,
figure this one out.
so is that how you're doing it? Because the way you have it written, it looks like you divided it and then you divided this number by this. So that's where you got the .0. Does that make sense? So like if you wanna do it in one step, you
Seven.
should- I would make sure you write it this way, so
On
that
B,
you remember not to like this.
cause I think,
Okay,
I don't know what I've done
I wrote it
here.
twice,
Yeah,
I wrote the 29 here, so.
so,
Number
Give me-
seven?
does it make sense though?
Yeah.
I did everything, oh, she, what have I done? I totally somehow messed up the, what did you get for this?
Number 7?
Yeah, what did you get for that?
Apparently,
When
no.
you first got to these over there.
I got 18.
Okay, hold on, number B?
Yeah.
I really like
Which
whiteboard
part?
sessions. People teach each
I
other
got
and I get
everything
paid.
right, except the six,
Right.
what did you get?
You
Did you get
deserve it.
6.52? So that's what I messed up, cause I was like, how in the hell did I get this all like this? Okay, let me see what I did wrong. I don't know how I got 18.
What you got?
Did you use this
Yeah, maybe .6.
instead of this?
That is what I got.
What do you mean?
Did you swap the numbers?
And
No,
that's
cause
what you scored.
somehow here,
Yep.
I did everything right, but I got
Because
this, I
it's
got
looked
18
up in-
somehow.
A
And I
good
don't,
question, did you use the
Put up in,
brackets
chart
properly?
For the actual.
I don't
Yeah,
know,
and
this
for
one,
this-
I'm about to
for this
find
column,
out
you're
how I
looking
did
for
this all
over
messed
the
up.
167. So what do you have to do when it's over? the
325.
Okay, yep,
Subtract
somehow I
that.
messed that up, so.
Yep, that's right.
So
No,
one
no,
minus-
that's
one
right.
minus
Yeah,
the-
325
this
over the
is-
square root of 25 is just,
Z-score.
It's
325 divided by 5 is 67.
Okay,
Yeah.
what did I do wrong?
You didn't do anything, right?
No, it was me. I was,
As far as I can
somehow-
tell.
No,
I
it's
am
me.
not a professor.
It's definitely me.
Let me check my answers here. Okay, number 6. Freddie, what number did you do?
I did 5 and 11.
Number 6, 8, 25.
Alright, let's see.
Number 6.
What did I mess up here?
1600.
Number 6?
How did I get 18 point something?
Yes.
I'm so lost.
Gotcha, subtract. Okay.
Oh.
7, 3, same thing. Okay.
So this is number 11 over here?
No, that is old. I didn't.
That's number 9,
Oh, what
from
am I
the other
doing
page.
with my life?
Not paying attention?
Negative. That is, I don't know what I was looking at.
6,
You
8.
did go to school, so you missed it.
Is this what you got? Or close to that?
The number 9
Well,
is on the other side, I did it. The number 9 for
Point
this one.
8.
The one minus?
Alright, yeah, I already changed
Well,
yours.
6, 8, 7,
This is your score,
9
right?
equals
Six.
point
What did I do?
1 minus 0.6, no, I mean, 0.7, 1 minus 0.72.
Where did you get 0.72? Hold on, hold on, hold on.
Chart, if it's, if I
Did
did
you
that
do
right.
negative 0.6 or did you do positive 0.6?
Okay, never mind.
What in the
I
world?
did, I think it's supposed to do negative. 743, supposed to do negative.
But yes, that is.
Okay.
These are critical for the whole course. You have to be able to do these.
Okay.
So be absolutely sure you know how to do this.
Wait, what's the year? Or 11?
You can't read yours.
Like I said, I may or may not have been half asleep when I was doing this. I got home from work last night and finished it, so I got lunch with my
I
friend,
have
instead of doing it this morning,
172.
because I was working on history from Thursday till Sunday.
You do good. Okay, is everything getting resolved?